Assalamu alaikum, sir. Myself Asad Muhammad Akib. My ID is 222156162. Today, my presentation topic is recurrent neural network or RNN. So, recurrent neural network. So, what is a recurrent neural network? So, it's an artificial neural network adapted to work for time series or data that involve sequence. Uses a hidden layer that remembers specific information about sequence. RNN has a memory that stores all the information about the calculations formed from feed-forward networking. So here we can see there is input layer and there are some hidden layers, and there is the output layer where that's the basic concept of the RNN. So this neural network uses the same weights for each element of the sequences need to information about the previous inputs before evaluating the results, and comparing the results to the expected value will give us an error. Propagating the error back through the same path will adjust the variables. Okay, so there is the simple concept that I have discussed here then for the recurrent neural network. Mm, so why recurrent neural network works? So RNN were created because there were a few issues in the feed-forward neural network. So feed-forward neural network cannot handle sequential data, considers only the current input, cannot memorize previous inputs, loss of neighborhood information, and doesn't have any loops or circles. So here we can see that in RNN there are input layer, hidden layer, and output layer. So in input layer we give the input, and hidden layers all the calculations where this happens, and output layer predict our output. So this is the architecture of the RNN. Here y is our predicted output, and O0 is initialized value at time when is 0. O1 is output at a time is 1. O2 is output at a time is 2. And T represents the time and W represents the weights. So there are four types of RNN. So one-to-one, which has a single input and single output, and this usually used for machine learning problems. One-to-many, there are single input but multiple outputs. This for image caption, and many-to-one, which has multiple inputs but single output, and it is used for segmented analysis, and many-to-many, which has multiple inputs and multiple outputs for machine translation. So here are the steps of training RNN. That initial inputs to send the same weight and activation function. Current state calculate by using current input and previous state output. Current state xt becomes xt minus 1 for second time step, and keeps on repeating all the steps. Finally, steps calculated by current state and final state and all other previous steps. An error is generated by calculating the difference between the actual output and generated output by RNN model. Finally, step 1 is process of propagation occurs. So there is the recurrent formula which denotes that ht equals to fw in multiply by ht minus 1 comma xt, where ht means the new hidden state, fw some functions of parameter of w, ht minus 1 which is old state, and xt input vectors at some other spent. Here are the O1, O2, O3, O4 which are the calculations and the formulas. Okay, so here's the example character level language model. Let's say our vocabulary is HELO, and example training sequence is hello, HELLO. So here HT equals to 10H. Here we are using 10H activation function. So tan h w h h h t minus 1 plus w x h x t plus bh. Here is the formula. So there is an image where we can see that how our input layer works and hidden layers and output layers are working. So vocabulary hello at least at test time sample characters once at a time, feedback to model. So here is happening backtrack. Okay, so here is our back propagation. So to reduce loss of function derivative of yi, so here is we denoted as small delta, so small del L divided by small del y I by chain rule wxh is dependent on xi, uh, small del L divided by small del y I. Okay, so here's the application of our RNN we can use in machine translation, text classification, captioning classification, or text to speech. So here are some advantage and disadvantage of our RNN. So advantage, input of any length, to remember each information throughout the time, which is very helpful in any time series predictor. Even if the input size is larger, the model size doesn't increase and weights shared across the time steps. Disadvantages, computation is very slow, training can be very difficult, using of ReLU or 10H as activation functions can be very difficult to process sequence that are very long, prone to problems such as exploding and gradient vanishing. So here is vanishing and exploding gradient. So how to identify a vanishing or exploding gradient problem? Vanishing weights of earlier layers can become zero and training stops after a few iterations. Exploding weights become unexpectedly large and gradient value for error persists over 1. So here is LSTM. Now I'm talking about. So for iteration LSTM, forget gate, input gate, and here is output gate, and there is long-term memory and pass update information. So here's the working process of LSTM. So for get xt input the current timestamp weighted associated with the input ht minus 1 the hidden state of previous timestamp, and wf is the weight matrix associated with the hidden state. So here is the basic concept that how LSTM works, and this is the main architecture. Okay, so gradient clipping, clipping by value and clipping by norm. A minimum clip value and a maximum clip value, and clip that gradients by multiplying the unit vector of the gradient with the threshold. Thank you.